Uh-oh. Kat?
Yes.
Hey, everyone. Abram here with Tom's Hardware. Welcome to the Tom's Hardware Show for May 24th, 2022. Um, as always, I'm Abram Pilch, Editor-in-Chief of Tom's Hardware, here with Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, Anne Barela from Adafruit. We're an engineer who works on the CircuitPython language. And as you may know, CircuitPython just got up. Was it just now? Just got up to 300 devices supported, which is just amazing. And I see in our audience we have Scott and Alyssa who also contribute to CircuitPython. So, Anne, what can you tell us about yourself and how you got started with CircuitPython?
Well, after graduating university, I worked for Boeing for a while, decided that wasn't so great. So I went into the diplomatic service for 30 years. But I really liked tinkering around with chips and hardware and software and from university days. So now it's probably been over 8 years ago, I started to pick that back up. And the hobby had changed in that Arduino was kind of this pervasive board. And so I started doing projects and at the time, and that caught Adafruit's eye. I was using their little original Trinket microcontroller, and the AT-Tiny 85 was different from the Arduino 328 chip. So you had to do some special things. And so I was learning about that, and Adafruit was interested and published some stuff. And so we got into this relationship, and they actually introduced me to Make, and I wrote a book on those kinds of things. So I was working with Adafruit kind of on a part-time basis while making sure the world was safe for democracy. And at a certain point, I was getting ready for retirement, and Adafruit asked if I wanted a new full-time gig. And I said, sure, this sounds great. And about that time, I was asked to write another book on the Adafruit Circuit Playground Express. A lot of people know about that board. And so I did write one. And this didn't just include Arduino. It actually focused a little bit more on two different languages, Microsoft MakeCode and a programming language that was kind of new and kind of featured on the Circuit Playground Express called CircuitPython, which was a fork of Micropython. And that's how my involvement started. I was working with Scott and Melissa and others in the chat to bring this platform into the mainstream, and it's really timely in that Python was becoming the educational language of choice. You all know that the Raspberry Pi Foundation chose Python and most educational institutions. So there's a lot of synergy there.
Yeah, no question about it. So what are some of the things that you have to do on a day-to-day basis in working on the CircuitPython language?
Well, Scott could tell you more on the nitty-gritty, but we have people working on the core functionality, libraries, which are functionality that are beyond the core, but maybe work with different types of things. For example, Circuit Playground has a number of sensors on it, and each of those require a library in which to interface with it. And Adafruit has committed to writing a lot of libraries to interface with sensors and motors and lots of different types of devices. We're talking about milestones. I believe there are over 357 libraries currently, and a number of those are third-party. People have contributed libraries because all this is open source. Adafruit licenses all their materials under MIT license, the software. So anybody can contribute. Anybody can grab it and hack it and tinker with it. So my involvement has gone towards two areas. One is community outreach. I do the CircuitPython, the Python on Microcontrollers newsletter, which reaches about 9,500 people each week. And that covers Python, MicroPython, CircuitPython. And I also work on the Adafruit learning system. People write guides, mainly these days using CircuitPython, and I curate and moderate that and help get those online.
Since you're so involved with the community, I'm curious, what are some exciting things that you've seen people do with CircuitPython that maybe you didn't expect?
I'm amazed at the broad range of projects that people have brought online. A lot of circuit boards, you say, oh, I can blink an LED. Well, I've seen some wonderful projects, not blinking one LED, blinking hundreds or thousands, or blinking them in relation to the air quality in which surrounds a person, or giving you a warning based on the UV index of a sensor in your sun hat, or something like that. It's the level of CircuitPython allows you to focus on your projects and a lot less on focusing on what hardware you're doing it with. So I tend to say you can channel all that other creative juice towards what you're doing, and people are doing it. There are wonderful projects. Some of them are highlighted in Raspberry Pi publications and Adafruit and other places where we're just amazed what people are doing with it, and making a tool in which allows that creativity brings a lot of satisfaction to us all.
Oh, I imagine.
Oh yeah, I mean that's the thing with CircuitPython. You've got these fantastic boards. I mean, 303 at the last count that I did today.
That's right.
303 boards, all varying in price from super cheap to decently expensive but powerful boards. Mm-hmm. But they all run this one OS, so to speak. That means they can just do the same code on every single board, even Raspberry Pis you can use it with. Yes. And you've got the libraries for all the add-ons that you can get, all the STEMMA Qt bits and bobs that will just attach. Mm-hmm. It takes away all the complexity for children or for makers who've not even touched electronics before to just get in and do it. And it's really simple. It just explains itself as you go along.
Definitely. I mean, you can take a board. This is like Circuit Playground, but this one has a Nordic chip on it, has Bluetooth, and I bolted a display on it. And the exact same code for this runs on this. The microcontroller architectures are vastly different. If you're going back down to Arduino, you're just going to bog down and give up if you really had to get into the nuts and bolts. If you're up at the CircuitPython level, you write code once and it runs anywhere. And it can run on the larger Raspberry Pi boards. I believe the number of single board computers, which are ones that run Linux or something like Raspberry Pi, is up to 88. So if you add that to the 303 boards containing microcontrollers, you're starting to push 400 boards that support CircuitPython.
That's awesome. And obviously we've got the work that Scott's doing as well for doing the bare metal CircuitPython.
Oh, that's been fabulous. I really wanted to try that, and the documentation for the chips at that level is very complex, and I have the utmost respect for Scott Shawcroft for working on all of those to get those up and running, working with the community who has some expertise in Raspberry Pi bare metal programming to get that up and running. So I think that will provide, barring the current shortage, another avenue in which people can explore CircuitPython and not have to worry about all the complexities of a full Linux operating system.
Well, that's it, because I'm from a generation of 8-bit coders, so Commodore 64s, Ataris, that sort of thing. Turn the machine on, there is your IDE ready to go, immediate. And it's that immediacy that I'd like to see with CircuitPython on a Raspberry Pi on bare metal. It would be amazing just to say to a kid, here's a machine, flick the switch, ready to go. Be awesome.
Well, a girl doesn't like to talk about her age, but a certain girl did work on those kinds of computers. And, I have a fondness of my own for them, mainly in the MS-DOS arena. But I had a Tandy color computer and played around in 8-bit BASIC myself. So I personally like to see things that are able to emulate or otherwise provide that same experience for a new generation without having to go to a boot sale or otherwise find a machine and then try to find all the software for it, make sure it's running correctly. There's a lot of layers in which to bring up an official retro board. I think one can get a lot of the same feeling and probably a lot of free software if you have something like a Raspberry Pi emulating them. And I'm looking forward to some of the emulation on microcontroller boards too.
Awesome.
Yeah, so I have to ask a somewhat off-topic question. What can you say about your computer that's behind you? Because that's pretty wild. It looks like an XP. I see Windows XP. I see a zip drive, and I think that might be a Shark drive above the zip drive.
Oh no, it's just a USB floppy drive. This is an XP and Windows 98 machine, circa 1999, except for a couple of the peripherals are a little bit newer, like the flat panel monitor and the DVD-ROM CD drive. The reason I have that at hand is that Adafruit's been working in Arduino and CircuitPython on being able to read floppy disks without the need of the older hardware or like a vintage chip to do that. And those libraries actually just came out. So having fun playing with archiving 5 1/4-inch floppies, 3 1/2-inch, and different formats, IBM, Apple, Atari. There's a lot of information around, and it would be great to be able to read those without proprietary software or proprietary hardware or expensive hardware. I mean, just the 5 1/4-inch drives right now are going around $100 each, which can put them out of reach of people. But if you've got a $4 Pico and you wire it up, and there you go. You have open source software that reads the flux and gets the data off. I think that'll provide a lot better adoption of wanting to tinker with things and maybe do some archival work too.
How would you read a floppy if you didn't buy the $100 drive? What would you use to physically read it?
Well, you do need a drive. I mean, that's kind of the bare metal is that, but a majority of existing floppies would probably be 3 1/2, and those are a lot more available and less expensive. So, yeah, unfortunately, if you do want to archive 5 1/4-inch drives, you need the drive, but you don't need the controller boards, the ancient boards, and then the full operating system and everything. You don't need a Pentium 3. You just use this as the processor and decoder.
So what you're saying is it's not all about the Pentiums.
Oh no. I mean that it takes away the need for Intel or Apple or somebody to do that. And again, the software is open source. There have been some proprietary solutions in the past, and that doesn't allow somebody to take the code and port it somewhere else. Say you wanted to make this into a clone MS-DOS machine. With a floppy drive, a keyboard, and a mouse, you could probably do that. But actually, going back, I hate to tout the Pi Foundation so much, but Adafruit just came out with preliminary support for USB host on the Raspberry Pi Pico using the PIO. And that's been demonstrated with the USB stack, Tiny USB, which Adafruit helps support in providing those extra USB host ports. So actually using the inexpensive Pico, it's a lot more possible to build a little retro computer just with this.
We had a question from Martin Parker that I'm curious about as well. He wanted to know, what is your favorite board to work on and why?
Well, I do have a fondness for the original Circuit Playground Express, but the SAMD21 chip is getting a little long in the tooth. You start to get that feeling like you want a little more horsepower, more flash, more RAM. So it's kind of split in two directions. I like the SAMD51 chip, which has, it's more the sports car chip, but that's kind of gone down into unobtainium. It's just not available on the market right now. But again, the RP2040 chip is available. The ESP32 line of chips is available when a lot of the other chips have not. So, barring, you can't get the Lamborghini, maybe the Jaguar, or a Range Rover might do just fine. And I'd put both of those chips into those classes.
That's interesting, because you say about the SAMD21 becoming a bit long in the tooth, and also there's the chip shortage right now. Adafruit has brought out a the RP2040 Trinket board which plugs in. So could we see more of those, do you reckon, in the future, replacing the SAMD21?
Well, the SAMD21 boards are very popular and they're very capable in the configurations. But if the chips are not available and people still want that functionality, like in a Trinket form factor or some of the other form factors, there's a good chance you might see it migrate to RP2040 or ESP32 level design, because those chips are available and you can put that same kind of thing, like a proximity detection or screens or whatever kind of peripheral you want, and actually have it in the store to buy rather than waiting for the chip shortage to be alleviated.
We have a question from Simple DIY Electro Music Projects. Would you say PIO is now as well supported for RP2040 and CircuitPython as MicroPython?
It's getting closer. In the latest release, there was additional PIO functionality added. And so if some of the folks who were originally drawn to MicroPython, because CircuitPython's PIO support wasn't quite as broad, might want to look at CircuitPython again. Again, there's a lot of programming that's involved in supporting all of that, and that means developer time, and that's allocated as far as what is needed now. And actually, a bit of the programming availability has been drawn towards the chip shortage also, and saying, okay, we're going to change a chip over to an RP2040 from a previous design. What programming changes does that require? Well, that takes time away from making all the other types of changes one might want. You have to prioritize.
That makes sense. Scott says USB host isn't hooked into CircuitPython yet.
I know, Scott. Look at the release notes for the latest version. Yes, with new features, we look to have people kick the tires and look at it all and try to do it. And we really welcome contributions. And one area that is harder than others is USB host. It's the work that was done recently in Tiny USB was leveraged off another open source project, which was brilliant, by the way. And that's what we love, is everybody working with each other to develop better functionality. So if there's anybody out there who's really into it, USB host or other functionality, post on the CircuitPython GitHub repository, and we'll see what happens.
So Kevin asks, do you think we'll see a merging of MicroPython and CircuitPython?
At the moment, no, but let me tell you some of the interaction between MicroPython and CircuitPython. CircuitPython was a fork of MicroPython, but all of the upstream changes for MicroPython are eventually added to CircuitPython. We're at par right now with MicroPython version 1.18. Version 1.19 of MicroPython is coming soon, and that has some breaking changes, and that will have to be reconciled with the versioning of CircuitPython. But having CircuitPython, it has allowed a lot easier mechanism for Adafruit and some of the community to contribute, and that's why you have 357 libraries and 303 microcontroller boards and 88 single board computers. The ability to innovate in some areas has progressed because of that fork. But I mean, Adafruit is very, very supportive of MicroPython. It wasn't one of these angry splits. On the contrary, there's collaboration between the two all the time, with the users, with the development team. Adafruit is a GitHub sponsor of MicroPython, and actively promoted MicroPython getting sponsorship through GitHub so they can further their development work. And they, with that kind of push, they just got over their goal of $5,000 a month in MicroPython funding, and they've set a new goal for $10,000 a month, which again we fully support, because every dollar flowing towards MicroPython helps MicroPython and the whole community, and CircuitPython draws from MicroPython.
Is there anything you could tell us about the future development of CircuitPython, or maybe just what would you like to see out of it?
Well, I used to say floppy and retro stuff, but I mean, they've already kind of hit that hard. If there weren't a chip shortage, I would tend to say working on some of the newer architectures. There's some really interesting chips coming out from the companies that might not be as well supported in the boards that you've seen. And the CircuitPython team is looking at the state of the art all the time. If there's something new with that's with more RAM, more flash, better peripheral support at a good cost point, then that would be a great candidate. One difference between MicroPython and CircuitPython is CircuitPython boards mostly require a USB port, so you can just plug it into a computer and it acts like a flash drive. And you copy over a regular plain text file as your code, and it just runs. MicroPython, you can code it a little bit more like an Arduino, where you take the code and you download it via a software on your host computer rather than the way CircuitPython does it. So they can do some different boards that CircuitPython might not, but I would definitely like to see it broaden. I'd like to have manufacturers say Python might be a premium, might be the language in which they're targeting their boards. And it seems to be going that way to a degree. The Sony's presence, they were very interested in having CircuitPython run on their single board computer. And we've, well, there's no financial understanding between us. They've coded their software and it runs, and they've shown ways in which their hardware is used. And one was in a recent Japanese satellite launch. And we love Python in space. I mean, I've got a sticker on my laptop that's CircuitPython in space. There are several satellites out there running CircuitPython, and that is really exciting. Now, if they'd chosen CircuitPython for the Mars, there you go. That's the sticker. That's it. If they'd chosen CircuitPython for the Mars helicopter, I would just be
over the moon.
Yes. Maybe someday, maybe a CircuitPython on Mars. That would be the next sticker that I'd have for you all.
That would be cool.
That is really cool.
Great. Well, thank you so much for giving us all those details. Speaking of details, I know, Ash, you had a really cool project that you've been working on recently.
I have getting some audio. There we go. I have a project that I'm actually developing, and before it's put together, I've been researching different ways to set up notifications. So what's going on with me is a need arose recently to regularly provide my dog with medicine on a consistent schedule. And I like to add a little bit of extra redundancy with things like that, just to make sure I don't forget to give her medicine. So to help with this project, I wanted to look into various notification options and thought it would be worth sharing with our audience how to set up and send email notifications with the Raspberry Pi. And it's fairly easy to get off the ground with this, and all of the tools we need are open source. And let me get my VirtualBox set up here. I have a Raspberry Pi OS running in a virtual machine that makes it a little bit easier for the podcast to show you guys what we're doing. So what I'm using for this particular project is called MSMTP. And on that note, actually, excuse me, just a second. Sorry about that. I'm having a slight technical issue. There we go. Sorry, I was trying to click in OBS instead of my virtual machine and it wasn't quite working. But I'm using an application called MSMTP. And what I used to use for email notifications was SSMTP, but apparently that has not been maintained in a while. And so the go-to SMTP application you want to look at right now is MSMTP. So to get it installed, you just run sudo apt-get install MSMTP space MSMTP-MTA. And what you'll need to do is configure this with a file to specify what your email domain is, the port that it uses, your username, password, things like that, so that your Pi can access your email account to send email notifications. Here's just a quick look at what that file might look like once you put it to good use. I didn't actually put my details in there because obvious reasons. The password that you'll need to use for Gmail, actually, you'll have to have two-step authentication enabled, and you get a special code through Google to set it up. So you don't use your actual username and password for this, but a special code from Google to set it up. But once you save this configuration file, you can open up a terminal window and run a command that looks like this. And you can specify the body of the email as well as the subject of the email. And with this, you can implement it with a batch file and set it up to run on a schedule. So in my case, that's what I want. I want to get an email notification at a specific time of day every day, just to make sure that I have a little extra, poke and nudge to say, hey, go give your dog her medicine. But you could easily, let's say you've got a board with CircuitPython running, right? And you're checking some sensor data, and maybe you want to send that over to your Pi and have an email sent saying, hey, this sensor is reading this temperature. Maybe you want to know whenever, I don't know, whenever it gets too bright outside or something like that. And it's just really easy to kind of integrate with other projects. And in my case, like I said, I wanted to just get notifications during certain times of the day. Well, that was basically it. I was going to get it up and running, but I had some issues earlier with Google getting my email address set up, so I can't run a demonstration. But that is what it looks like whenever you run it in terminal. And like I said, you can set it up with a bash file to have it run automatically. But what do you guys think? Have you used email notifications before? And if so, what notification tools have you used to set that up? Because I ran into a hurdle this morning when I figured out SSMTP wasn't around anymore.
Nice. I've done it in Python before, at Pi Academy many years ago. And that was handy because we had a group who wanted to take a photograph every 15 minutes, say, and then have that photograph emailed to another department in their school. And they managed to do it quite simply using, I think, about 15 lines of Python, which was awesome. But for notifications, I've done something with Windows. I think it's called Toast or Toaster. And it just like pops up a notification in the bottom right of your screen. And I had that linked with Python. So whenever a new news story came out in our RSS feed, it popped up in the corner saying, hey, look. Which I thought was quite cool. That was years ago I did that.
That's really good. Yeah, I like how easy it is to have something so simple, like just simple notification, but you can implement it with so many different projects. You know, find the right sensor, pull your data in, have it send you an email with a little piece of data, whatever you want, or maybe that a certain threshold of that data will trigger the email. Yeah. It's just really easy to get off the ground with email notifications, and I think a lot of people kind of overlook that. And there's also ways to get text message notifications, but I can get into that a different day.
Yeah, it's so important to be able to have your system notify you of stuff, particularly if you have it doing something important like monitoring something. So, Les, what have you been working on this week?
Well, this week, in honor of Anne being on the show, I had to do something in CircuitPython, really. It's a done thing. So I thought, what could I do? So I thought, well, let's see if I can get CircuitPython boards to work with Chrome. So I've got a Chromebook, a little Lenovo GS, and I quite like it. It's a nice little machine. And I've got it connected up to this board here. So the MakerPi RP2040 from Citron. Great little board. It's there for robotics. And this is running CircuitPython. And it's got some code running on it already. You can see the neopixels are just changing color right now. That's at the left and right of the board. And if I press a button, you'll see, there's a wheel there, by the way. You'll see it all comes to life, and servo comes on, makes a noise, wheel turns up, that sort of thing. And that's all done in CircuitPython. So I'm going to show you quickly. And this has been a test. I've never actually connected my Chromebook via video capture to this system before, so it was quite an ordeal to get this working. So hopefully it's not going to crash. So you can see on the screen right now, this is my Chromebook, and that is the files window, Explorer window, I should say. And there is the CircuitPy drive. And you can see, come on, machine. There we go. You can see there's code.py ready to go. And I've got this open in a text editor, and this is called Carrot, the text editor. And it's a very simple text editor, but it works. It does the job. And on here, I've got Citron's default code to just test their boards and show that it all works. This is in CircuitPython, obviously, and it's just make motors spin, make noises, make lights, which is what we want. This is our demo to see if it works. So this has been saved to the board. So if I just quickly save it now, you hear Mario, and it plays some song, little audio for us there. But to see what's going on the board, I needed a serial emulator. So this is Beagle Term. And this serial emulator lets me use a USB device, in this case, a CircuitPython device, to see what's going on. So right now I can see that it's just auto-reloaded. So I press Control-S to save. When you save on a CircuitPython drive, it auto-reloads all the code ready to go. But if I was to stop this now, just make sure I've highlighted that, I can drop straight into a REPL, and I can type away the good old hello world. all from CircuitPython on a Chromebook. Now, this is based on an Adafruit tutorial that I found today, and relatively simple to do this. It hasn't been difficult. I'd like to see it all in one application. So there's the Mew application by Nicholas Tollevay, which is an awesome piece of software, which isn't on Chrome, unfortunately, but it's on Windows, Mac, and Linux, and that works. But I'd love to see something like that. So one application where it all just works in one application. That would be awesome on a Chromebook, because these Chrome devices now, they're being dished out to schools left, right, and center. And they're cheap, they're easy to maintain, and if we have cheap hardware for the kids to use, so a cheap Chromebook, some cheap Micropython and CircuitPython devices, we can get the kids hacking and making really cheaply, really quickly.
You mentioned that you found an Adafruit tutorial for this. Just got to take a second to recognize Adafruit has a lot of really well done tutorials. And this morning, when I was trying to find different email notification systems, I came across a couple of Adafruit guides that had different options for setting up email tutorials. So definitely check out some of their guides.
I keep the NeoPixel tutorial in a bookmark ready to go so I can remember how to use the command.
Yeah, no question. It's just amazing. Like, I just speak here as an editor who writes and edits how-tos, that the tutorials on the Adafruit site are so fantastic. Like, they're just, you guys just do a fantastic job of writing and editing them and formatting them and keeping them up to date. I mean, it's
Scott just said she's the main
Anne
editor.
does it.
Thanks,
fantastic.
Anne. Thank you. That's great.
Credit to you.
I do edit those. I mean, we have a whole host of authors. I mean, very smart people who write guides. I just help foster their stuff. I've written a few guides, obviously, and we have some formatting, some ways in which we like to see them. But again, they're all open source. There's no fee. There's no, just absorb it and use it. And again, there's a lot of hardware and stuff that isn't Adafruit's. I mean, it talks about Chromebook and those applications. They're not Adafruit applications. We're not trying to upsell you on something Adafruit. Go ahead and use them, hack them. The creativity involved in using that kind of material, Adafruit just reaps some of the maker movement effort in that. And I love that. I just love the cooperation in the maker movement. And that's one great tool, and I'm happy to be a part of it.
Yeah, that is absolutely amazing. Well, before we go, I wanted to do my quick show and tell for anyone who's remotely interested. Yes, Adafruit Guides are free education. Yes, Adafruit Guides are amazing. Like, I wish half of our tutorials could be as good as Adafruit's. They set the gold standard for sure. So if you, like me and probably many people here, ever have to, say, use a Raspberry Pi, your PC, laptop, maybe more than one Raspberry Pi, you would want a keyboard and mouse combination like this one. Just came out today, the Logitech MX mechanical keyboard and the new MX Master 3S mouse. And they're not the only mice or keyboards in the world that do this, but they do a particularly good job of allowing you to switch among three Bluetooth profiles. So there's keys. I don't know why my keycap is off here, but there's keys on here that actually are devoted for each profile. So you just hit the key on the keyboard and you switch on it, and you switch quickly. And then with the mouse, now they've had other versions of this mouse before, but this is the new one that has slightly higher DPI, right? I have the old.
Hold up, sorry.
Anyway, so they use, if you're on Windows or Mac, unfortunately not Linux, you can use a feature called Logitech Flow, which will allow you to kind of treat another computer as part of your desktop. So you could put I'm on my desktop, I can put my laptop sitting over there and then drag the mouse. And once it drags off of the edge of the desktop, not only will the mouse switch profiles to the other machine, but if you're using this keyboard with it, the keyboard will switch too. So you won't even have to hit the button. They'll just synchronize with each other, which is what is kind of new about the keyboard, because they had a keyboard before, but it wasn't mechanical, and no self-respecting geek will be caught dead using a non-mechanical keyboard, I think. So this is available with blue, brown, or red switches. So you can use it for that. If you are using a Raspberry Pi or another Linux device, you can still use these, but you can't use Flow. You've got to use the manual button to switch to it. So you use the button on the bottom here to switch the mouse, and the button on the keyboard to switch the keyboard. It's unfortunate. It's unfortunate that they haven't made that support for Linux, nor is it open source. But still a really nice set of peripherals for people who have to work across multiple devices, which is something that I know probably a lot of us have to do. So I want to thank Anne so much for joining us and sharing her wisdom and experience.
Yep.
Thanks to all of you for listening and watching. We are here every Tuesday at 2:30 p.m. Eastern, 7:30 p.m. UK time. And we look forward to seeing you next week. Bye, everyone.